Hello, hi everyone. Welcome to the Student the Brand. This is our Shiva sir. Today we are going to discuss about light reflection and refraction. Light reflection and refraction chapter. Light is a form of energy which gives the sensation of sight. Light reflection and refraction chapter. Okay, done. So, light reflection and refraction. So, I'm taking the plane mirror. This is a plane mirror. Plane mirror. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. And this is the undeviated line. Undeviated line. So angle between incident ray and normal line is called angle of incidence. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. So now you can see here. Now you can see. Okay. Loss of reflection we'll discuss about. Loss of reflection. Loss of reflection. Loss of reflection. So what is the reflection of light? The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Okay. Loss of reflection. Now we are discussing loss of reflection. Point number 1. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. So coming to the second one, angle of incident is equal to angle of reflection. These two are very important. Loss of reflection. The first one, angle of incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Okay. Now, angle of deviation we have to find out. Angle of deviation. Now you can see here. Angle of incident, linear angle is 180 degrees. Linear angle is 180 degrees. Now, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. We know from loss of reflection, angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Now angle of deviation equal to 180 minus 2 angle of incidence. 2 angle of incidence, right? Now, angle of deviation, so we can write in another form, angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. I hope it is very clear. So, angle of deviation is, so 180 minus 2 angle of incident, angle of deviation equal to 180 minus 2 angle of reflection. So, here from loss of reflection, angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Loss of reflection, incident ray reflected in normal line. Angle of incident is equal to angle of reflection. So Linear angle is 180 degree. Angle of the incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From loss of reflection, so in the place of angle of reflection, I substitute angle of incidence. So angle of deviation equal to 180 minus 2 angle of incidence, and angle of deviation equal to 180 minus 2 angle of reflection. I hope it is very clear. Next one. Now regular reflection, irregular reflection we'll discuss. Regular reflection, irregular reflection, regular reflection. Regular reflection, I am taking the plane surface here. So incident light rays are parallel to each other. So these are the incident light rays. These are the incident light rays. These light rays are parallel to each other. So reflector light rays also parallel to each other. Reflector light rays also parallel to each other. So this type of reflection is called regular reflection. Regular reflection. Incident light rays are parallel to each other. Then reflector light rays are also parallel to each other. Incident light rays are parallel to each other. Then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. And also we can say still water, still water. Plane mirror, regular reflection takes place on plane mirror and still water also. Coming to irregular reflection, irregular reflection, irregular reflection, irregular reflection, irregular reflection. Okay. Now, so I'm taking irregular reflection like this. Incident light rays are parallel to each other. Incident light rays are parallel, but reflector light rays are not parallel to each other. Okay, incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Here incident light rays are parallel, then reflector light rays are also parallel to each other. So this type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection takes place on rough surface. Best example you can take wall. On wall irregular reflection takes place. There is one question related to this one, that is uh, wall reflect light rays and plane mirror reflect light rays. So listen carefully. Wall reflect light rays and at the same time plane mirror also reflect the light rays. So what is the difference between their reflection? So give your answer. So what is the difference between their reflection and give your answer? So the answer is wall reflect a irregular reflection because surface is irregular. So irregular reflection takes place. Irregular reflection is also called diffuser reflection. So coming to plane mirror, on plane mirror regular reflection takes place because Yeah, so surface is very smooth. Okay, highly polished smooth surface. That is called plane mirror. Incident light rays are parallel and reflector light rays are also parallel to each other. Incident light rays parallel, then reflector light rays are also parallel to each other. So that type of reflection is called regular reflection. Here irregular reflection. Okay, now so we'll discuss one more, that is okay, done. Object and image. We'll discuss about object and image. Real object and virtual image. Real image and virtual object. We'll discuss. Real object. Okay, so from this point, light rays are coming after reflection. The light rays are moving away from it. One light ray I am taking like this. Another light ray I am taking like this. So those are moving away from it. These light rays are moving away from it. Okay, if you are extending those light rays, here you cannot see. There virtual image will form. Virtual image. And here also virtual image. So here real object and virtual image. Real object and virtual image. Real object and virtual image. So we are extending this reflector light ray. So this is the incident ray 1, incident ray 2, reflected ray 2, reflected ray 1. So we are extending this reflector light rays. Reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Virtual image. So now you are considering here. So here light rays are coming from infinity after reflection. Light rays are coming from infinite after reflection. These light rays are meeting. Okay, so if you are extending the incident light rays, here, so this is the real image and virtual object. Real image and virtual object. Okay, real image and virtual object, real object and virtual image. Now you can see here. Object and image. Object is real, image is virtual. Object is virtual, image is real. Okay, once again listen carefully. Listen carefully here. Okay. So object is real, image is virtual. Object is virtual, image is real. Here we are extending the reflector light rays. So extended reflector light rays are meeting at one point. There virtual image will form. So we are extending the incident light rays. Extended incident light rays are meeting at one point. There virtual object. Okay, so directly reflector light rays are meeting. So that point a real image. So the point of intersection of reflector light rays is called real image. So the point of intersection of extended reflector light rays is called virtual image. Object is real, image is virtual. Object is virtual, image is real. Okay, so this is about object and image, virtual object and real image, real object and virtual image. And coming to the nature of the image formed by the plane mirror, nature of the image formed by the plane mirror will discuss. Okay, done. Ready to start here. So virtual image, virtual image, virtual image, virtual image. Okay, so this is the object. So how many light rays are required to form the image of the object? Minimum 2 light rays I am taking like this. And here also. So A dash and B dash. Now you can observe here one thing. Object is real, image is virtual. Object is virtual, image is real. Object is real, image is virtual. Object is virtual, image is real. Right? Point number 1. Object is real, image is virtual. Object is virtual, image is real. Coming to second one, the distance between object to mirror. So is called object distance. The distance between mirror to image is called image distance. Object distance is equal to image distance. Coming to third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Coming to fourth one, magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So fourth one, magnification of the plane mirror is +1. And coming to the fifth one, last one. Okay, so it also shows lateral inversion. Lateral inversion, the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay, lateral inversion, lateral inversion, lateral inversion. Object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image. And the magnification of the plane is +1. Magnification of the plane mirror is +1. And it also shows lateral inversion. Sir, what is lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Okay. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion. Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Lateral inversion. Okay, I hope it is very clear. Okay, so coming to one more. Spherical mirrors. We have to discuss about spherical mirrors. Shall we discuss? If you click on like button, we'll continue. So, because already time 11 o'clock. Are you ready? Okay. So next one we'll discuss about spherical mirrors. Spherical mirrors. Spherical mirrors. So a part of the sphere we are taking. So part of the sphere, that is called the spherical mirror. So depending on the reflection, okay, so mirrors are divided into two parts, concave mirror and convex mirror. Depending on reflection of light, mirrors are divided into two types, concave mirror and convex mirror. Concave mirror, convex mirror, concave mirror, convex mirror. So concave mirror is also known as converging mirror, whereas convex mirror is known as diverging mirror. Um, so after reflection, light rays are moving towards the principal axis. Light rays are moving towards the principal axis. So concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror, because after reflection, the light rays are moving away from it here. Okay, so after reflection, light rays are moving away from it. That's why it is called diverging mirror. So after reflection, light rays are moving towards the principal axis. So towards the principal axis, that's why it is called converging mirror. This is called diverging mirror. So thank you so much for joining and attending. So we'll discuss in the next class. So a few more topics. So thank you so much. So do like, share, and subscribe to Student Independent. Thank you.